Hi, this is Don, and I want to show you some quick ways using StatCrunch to determine the critical values of your hypothesis tests. Let's go up here to Stat, and we'll go to Calculators, and let's do a normal z-test first of all. Here's our calculator. We're on Standard, which shows either a left tail or right tail test. Right now it's a left tail test. Let's do a right tail test, and I want the alpha to be 0.05, which is a 95% confidence level, so we'll put in 0.05, and then I hit compute. And we get a critical value of z of 1.6448, or rounding out to three places, 1.645. I think you've heard that before. Well, what if we wanted a left-hand test, and I just switched that and let it recalculate the z, and you see we get the same critical value z, minus 1.645. You would expect that. Okay, but what if we've got a 95% confidence level and we've got a two-tail test? Well, the calculator doesn't have a way to do a two-tail test, but what we can do is just remember that in a two-tail test, the probability beyond the critical value is half of alpha. So I'm going to put in 0.025 and compute, and we see that on the two-tail test for 95% confidence level, the critical z becomes 1.96, and you've seen that before. Now I could switch this around and recalculate, but we know that the normal curve is symmetrical. Therefore, the right tail of the two-tail test is going to be the same but positive, so it would be a plus 1.96. Pretty straightforward. Okay, let's do a t-test. Again, I'm going to calculator, down to t, and here's our t calculator, and we got the standard again. We want either a left tail or right tail test. This time we have to know the degrees of freedom. And let's say our degrees of freedom are 4, n minus 1, and that, again, we're using the good old 0.05, 95% confidence level, and I compute the left hand, which is a minus 2.132 for the critical value of t. If we want a right hand test, we know it'll be 95, but I'm going to just for fun put that in there again and recompute, and we've got positive 2.132. Pretty straightforward. Now let's do a chi-square. It's going to be similar. Different shaped curve, of course, and the chi-square distribution depends on the degrees of freedom. And we're going to say this time we've got degrees of freedom of 6. And I want our 95% again, 0.05 for the alpha. And I compute, and I want this to be right hand, because normally with a chi-square we're dealing with right hand distributions. And the critical value is 12.592. Okie doke. The last calculator I want to show you is for the F test. We'll go to Stats, Calculators, F, and here we have the F distribution. Remember that the F distribution is not symmetrical, so we have to determine separately the area under the curve for a left tail test or a right tail test. In this test, we also need to know the numerator and the denominator degrees of freedom. And you would put in the values you have. I'm going to leave the 25 they have here. I want a 95% test, and it's going to be first a right-hand test, and it computes a value of 1.955 for the critical value of F. Anything beyond that, larger than that, falls in the rejection region, and we reject the null hypothesis. If we want a left tail test, just like that, and for 95%, recompute, and we get a value of 0.511 for the left tail test. It's a positive 0.511. Anything smaller than that falls within the rejection zone and you reject the null positives. And that's it.